Good afternoon. I hope you've all had a nice lunch. Welcome back to our final two sessions of Standards in Action. So we've got 4 presentations of 20 minutes, then we'll take a break, and then there's a final 4 before we finish off. So our first presentation this afternoon is from Haoru from Wuhan University, Changan Joint Laboratory for Geospatial Information Technology, and he's going to talk about enhancing high-definition maps for level of detail concepts for autonomous driving.
Okay, hello everyone. My name is Haoru, and I will be on behalf of the Wuhan University Changan Joint Laboratory for Geospatial Information Technology to give a representation about enhancing high-definition map with level of detail concept for autonomous driving. Okay, here is the outline. So I'll begin by introducing the background of the high-definition map, and then I will introduce the concept of the level of detail, which originally generated in computer.
주변으로 해서 엑셀 사이즈가 몇 바를 몇으로 해야 된다. 아니면은 최소한 몇 기가로 나타낸다. 이런 식으로 그 단위라든지 크기.
Okay. Go ahead. Okay. So the second part is the concept about a concept of the level of detail, which is generated originally in the computer graphics, and I'll adapt it to organize the HD map. Then the third part we come to the HD map model, and finally give a conclusion. Okay, let's come to the first part. So high-definition maps were born out of the needs for autonomous driving. As a foundation, knowledge repository, and spatial reference for automated vehicles, HD maps support data vehicles characterized by accuracy, richness, dynamism, and reliability. So HD map plays an important role in the automated driving with several relevant stakeholders such as map manufacturer, car company, and regular authorities and organizations and individual users. So there is a great need for those people to exchange and sharing the HD map products. For example, maybe the TomTom may want to share their updated map data to the BMW. Okay, so a unified HD map model is imperative to be established. So here we can see there are many rich data elements in the HD map. For example, including the road network, the land network, and the furniture, the POI, the localization feature, and so the HD map model should contain all these rich road and traffic data to meet the needs of the automated driving. So as the SAE defines several levels for the autonomous driving, from the level 0, which is no driving automation, to the level 5, which is the full driving automation. So several kinds of maps are used to with different precision to meet the different AD levels for the automated driving system. So for example, the SD map, which we call the standard definition map, we use it to meet the level 0 and the level 1 of the automotive driving. And the ADAS map, which we call the Advanced Driver Assistance map, is used for the level 1 and the level 2. And finally, the high definition map for the from the level 1 to the level 5. So the HD map model will organize all these map data at different levels to meet the different AD levels of automated driving system. So there is some existing existing HD map models like OpenTNF, the Lineage 2, the GDF, and NDS, OpenDrive, LDM. They are all excellent works. So hopefully, based on their efforts, the HTML will put forward this work, especially in the map elements, the provenance, quality, and updates representation. So actually, it has been 2 years for us to begin investigating how the ISO and the OGC baseline, like CDGML, GML, and ONM, to be used in the representing of the HD map data. So in the September 20 and 23, we give the representation about the data quality of the HD map. And in December 2023, we submit the HTML swag to Scott. Yeah. And in the March 2024, we give a presentation about the HTML swag proposal. And in the September 2024, the transportation and the mobility DWG was established. And then, based on all this investigation before, we proposed the rationales in designing HTML, including the level of detail and the integration of map and observation in the member meeting, policy member meeting in Goyang. Yeah. And in the January 2025, we began to have a discussion with the ISO TC 211, JWG 11, and ISO TC 24 work group 3. Yeah, we give a discussion about how to put forward the map data standard together with the GDF. Okay, it comes to the second part. We'll give a brief introduction of the concept of level of detail. So the level of detail was originally introduced in computer graphics to increase the efficiency of rendering by decreasing the workload on graphic pipeline stage. So in computer graphics, the LD refers to the complexity of a 3D model representation. The level of detail can be reduced as the model moves away from the viewer or based on other factors such as the object's importance, its speed relative to the viewpoint, or its position in the scene. So that's the concept in that's the original concept. So after the concept of the LD generated in the computer graphic, people find it can be used in other domains with its concept adapting. For example, the LOD in CDGML formalizes a multi-scale spatial representation, focusing on the varying geometric resolution to support applications like visualization, simulation, and analysis across different spatial scales. But LOD in BIM, it defines the progressive enrichment of both geometric and non-geometric information of a building object through its life cycle stage, from the design to construction and operation. So we can see the concept adapting. So in the HTML, the level of detail, we think it represents a hierarchical abstraction of map information, where high level progressively contain the richer and much more structured and more precise spatial elements for autonomous driving applications. So we take the perception data, which contains no explicit map elements, as the LOD0, and the SD map with basic map elements as the LOD1, and the ADAS map with enriched road elements as the LD2. And finally, the HD map with detailed land level elements as the LD3. So let's come to we give a brief introduction to the LD0 first. So the perception data, we say it has evolved from being the foundation for over the mapping, offline global mapping to the enabling real-time local environment construction, and ultimately achieving end-to-end autonomous driving control with its value as fundamental data continuously deepening. So we can see the perception data plays a more and more important role in the autonomous driving. So that's why we take the perception data into the map model. So the perception data, we think it can be organized by 3 levels. That is the scene level, the sample level, and the frame level. In the frame level, perception data includes the information received by the sensor at a specific moment, primarily used for dynamic monitoring, such as detecting and approaching a pedestrian. So it's like a photo that's captured by the camera. So the frame level data is especially used for the low latency, low capture frequency sensor, like event-based cameras, analyzing the differences between the consecutive frame allows for quicker detection of a dynamic change in the surrounding environment. And in the sample level perception data include the key frames sampled from the sensor collected frame data, primarily for the purpose of the local mapping. So the key frames are selected by the local mapping algorithm using the specific strategies, such as fixed frequency sampling. This is to reduce the volume of data while returning essential spatial and environmental detail. So sometimes the sensor captures so many data that we just need to use some of them. So we take the sample level data for people to use in this situation. And finally, in the scene level, perception data includes data collected with the same scene, typically applied in the scene mapping task, such as mapping of underground parking. So the perception data can also be categorized by the scene to distinguish between the data collected under the different environmental conditions. So this enables customized data processing that account for the environmental factors. So this is a perception data. Okay, let's come to the LD1 is the SD map, a standard definition map. So I think it is the common map data in our life. And I think it's hard for us to live without the standard definition map now. So the famous SD map data is the OSM map. So it contains many road features and POI features. And the LD2 is the ADAS map. So we can see it containing the hidden feature and the ADAS road feature. So which the road with gradient and curvature. So the ADAS map can used for like the application like cruise control. Yeah. And the final part is LD3 HD map. So the HD map containing the rich road elements such as the crosswalk, the signal lights, and other critical facilities. It can meet the needs for the high-level automated driving. Okay, let's come to the HD map model. So this is an overview of the HD map model. So we can see there are several modules here. Let me introduce it from the top to the bottom. So from the top, we can see the change set module. So every HD map data set, it has the attribute of change set. it can record the change situation of the data set. And every HD map data set, it can contain several HD map data. So it's here. So the HD map data set, it can contain several HD map data. And the HD map data, as I have talked before, it contains the LD0 feature, that is perception, and the LD1 feature, that is the SD map features, and the LD2 feature, that is the ADAS feature, and the LD3 feature, that is the HD map feature. And then we can see the rich elements here. That is all the map elements. For example, the POI, the heading, and the lamp. So this is all the map feature. And all these map feature class are generated from the abstract map feature, which is the subclass of the abstract feature in GML. And in the bottom, we can see we use the lineage and the data quality to record the quality and the provenance of the map data. So every feature, it can record the quality and provenance. So this is an overview. Okay, in this slide, I'll show how the map model records the provenance in the feature. So here is an example. So there is several features which are extracted from the camera by the MapTR model. So every feature, it has the lineage attribute. It records the data source. That is how this data is generated. So we can see this data is generated from the image data. And the data procedure is used to record the procedure of the data process. So we can see it records the model, that is the MapTR model. So this feature is generated by the MapTR model. So this is provenance. And this slide shows the quality representation in the HD map model. So still the same example, that is the feature extracted from the camera by the MapTR model. So each map feature extracted by the MapTR model has an associated confidence score. So we can see here. So every feature has a confidence level. It records the confidence of the feature. So based on this, we can use the data quality model in the ISO 19157 to record this quality information. It contains the main reference, the evaluation method, and the result. Okay. So this slide shows how the map model to record the update situation. So we can see that every data set has a part to record the change set. So the change set record information contains the 4 parts. So the first part is the basic information. It has the information, for example, ID, the data set ID, the version, the change count. So the other part is all the data that has changed. For example, the added data and the modified data and the deleted data. So this is the update of the HD map data set. So in this slide, I'll introduce how this map model represents the situation in the real world. So there are several scenarios in the real world that bring many challenges for the HD map data to represent the road situation. For example, the highway, it brings the challenge of the multi-lane topology, and the urban main road, it brings the challenges for the dynamic urban element fusion, and the GNS denied localization for the tunnel. 3D spatial topology for the viaduct, and multi-lane crossing logic for the junction. So they all have their own characteristic, and it brings the special challenges for the HD map model. So I think we will validate our model in all these scenarios. So here I just take the junction for example. So here is the junction in the real world. It looks very complicated, and there are many informations. So the first step we should do is to delete the information that are not relevant to the map data. So we abstract the junction into here. So it's the junction in abstract. So it's still very complicated because the road they gathered together. So next step we should split the road into different parts. So we can see here they have the straight road, the near side turn, and the far side turn. So totally we can split for the, I think, 14 road in total. So after split the road, we can split the filter for the lane. So each road, we can see here it has several lanes. So we can see here is the central line as the reference line, and we can record the information of the lane near side the reference line. So we record the reference line in the LD1 feature and the lane in the LD3 feature. Okay. Okay, finally, it's the conclusion. So I think we propose a novel high definition map model that organizes and presents rich map elements based on the concept of a level of detail in order to meet the varying needs of autonomous driving systems and different levels. And we improve the capability of the HD map model to support representation in provenance, quality, and change set. And through the practical case study, we demonstrate how the HD map model can be used to structurally encode and represent a real-world environment. So in the future, I think we will advance the development of high-definition map markup language standard and apply the model across diverse world environments and intelligent vehicle platform to validate its generality and scalability. Okay, that's all. Thank you.
Thank you very much. It's great to see that that work is progressing. Consider detail behind each. And I've got time for one quick question. Does anybody have a quick question? Chongqing.
Thank you for the excellent presentation. Actually in the joint working group with ICT Server 204, so I've seen that part of the presentation presented at their meeting. And my question is that the LOD concept is really good, but it's a little different from the what CDGML generally. CDGML version 3 defines the level of detail there. So it might confuse people that the HTML has different ideas of LODs than the CDGML 3.0. So you might think about how we can actually sort of negotiate, so that try to minimize confusion on people's side in terms of LODs.
Oh, so you mean how to negotiate between the CDGML and the HTML?
Yeah, it could confuse people that the LOD in HTML is different from what CDGML defines LODs.
Yes, I think it's a very good question. Because there is some difference between the LOD concept in CDGML and the HTML. But I think they can negotiate here because the LOD concept in HTML is the features of the element. So this is the different aspect with the CTGML. CTGML LD is some attribute of the feature. So, right?
We'll talk later about
As it is some aspect of the feature, but not the visuals of element. So we think maybe in some way we can put them together. For example, in HTML, now in HTML, the feature has no concept like the LD CTML. Maybe we can edit it. Yes.
Yes.
Yeah.
Right. Thanks for the question. So I'll keep that's probably given plenty of time to think about that, chat about that to the coffee break.